Hello and welcome to another virtual episode of NASA Science Live. I'm your host, Joy Ung, and I'm so happy you could join us today to hear an exciting announcement about our sun. First, let's learn a little bit about our star. There's a rhythm emanating from the sun to the edges of the solar system. Roughly every 11 years, our star ramps up to a turbulent state, expelling violent eruptions. After a peak, it calms down to a quieter phase before starting all over again. This is known as the solar cycle. This ebb and flow of solar activity affects the entire solar system, including spacecraft electronics and astronauts that can be affected by particle radiation if they're not sufficiently protected. Understanding the solar cycle is one of the oldest problems in solar physics, and now predicting it is more critical than ever as we venture to the Moon, Mars, and beyond. So today we're joined by three experts. We have Dr. Nikki Fox, Heliophysics Division Director at NASA Headquarters, Dr. Elsaya Talat, Director of the Office of Projects Planning and Analysis at NOAA, and Dr. Jacob Bleacher, Chief Exploration Scientist at NASA Headquarters. Thank you so much for joining us today. So Nikki,
thanks for having us.
Can you tell us what the exciting news is?
I can, yes. Today we're very excited to confirm that we are in a new solar cycle. So we have entered solar cycle 25. And that's important for us because it means we're going to see a whole new aspect of our star again. The way that we traditionally characterize a solar cycle is by counting the number of sunspots that you can see on the disk of the sun. And so when we're at a minimum, as you see by those little valleys there, that's what we call solar minimum. And then as you get to the peak, that is solar maximum. And so we see very, very different types of activity on our star. And we're excited that we are heading up for another solar cycle. You see there in the video, solar minimum, just one or two of those little dark spots on the disk of the sun, solar maximum, lots of them. What that corresponds to is a not such an active star at solar minimum, but boy, look at all those wonderful active regions that you can see there at solar maximum. So it's a great time to be a heliophysicist.
Wow, that's really interesting. So I'm curious to know what happens during each phase of the cycle. What does an active sun mean?
So there are all kinds of different things on our star. So at solar minimum, we tend to see a fairly uniform circular disk or sphere with not too much activity in it. That doesn't mean that it can't throw something our way. It just means that it becomes more probable with more and more of those pockets of activity in around the equatorial region of the sun. That's exactly where we are sort of sitting on that plane here at Earth. And so that means that we are once again in kind of the target region for big solar activity to come our way.
So this is a question for all of you. Why is following the solar cycle important?
So I think we're all going to have a slightly different aspect to this. As a scientist, as a the heliophysics scientist, I am just excited about the star in general. We live with a star kind of in our backyard. So we can actually, even though it's hard to do, we can send missions right up to very close to our star. We can really study its impact. We can study how the activity changes, how it impacts our planet, how it impacts well beyond our planet, and of course, how it shapes our place in the universe as we are orbiting the Milky Way. And you see, of course, their Parker Solar Probe up there, really, really close to the sun, making measurements in the actual atmosphere of a star. So that's why I'm interested, but Elsaya and Jake will have slightly different perspectives to add.
Yeah, so Nikki, from our perspective, NOAA's responsibility is to provide the operational space weather products and services that meet the evolving needs of the nation. As we move towards solar max, we're preparing for an increase in solar and subsequent space weather. This solar activity manifests in various explosive waves. Solar flares, which are bursts of electromagnetic energy coming from the sun, and these are often accompanied by energetic particles that can travel about half the speed of light. And some of the biggest explosions that we see off the sun, the coronal mass ejections. These are expulsions of plasma and magnetic field from the sun's outer atmosphere, the corona. and they can eject billions of tons of coronal material at millions of miles per hour into interplanetary space. All of these events can impact our technological society and our space commerce and exploration.
Yeah, and just as understanding what the sun is doing and how it impacts us here on the Earth and around the Earth, NASA also cares about how that impacts our assets out in deep space. It's a really exciting time for human exploration. We're moving beyond low Earth orbit, sending astronauts to the South Pole of the Moon through the Artemis program. These astronauts on these trips, they're going to be exposed to time periods where they're outside of the Earth's magnetic field. And that's what protects us in some ways from that solar environment. So for us, it's really important to understand what the sun is doing. What is it doing under normal conditions? What is it doing when unique events are occurring? Because if we can understand that, well, I like to call it, we can predict, prepare, and mitigate. So understanding from our colleagues what the sun is going to do, what the environment's going to be, helps us protect our astronauts and our hardware.
So our star goes through a roughly 11-year cycle. Do other stars go through a similar cycle?
So we certainly see other stars that have kind of weather like we do. So like we have our solar flares and our solar wind, we do know that there are other stars that also we see stellar flares. They can be much, much bigger and more violent than ours here on our sun. They can also be much smaller. And we do know that other stars also expands away. But the key for us is we can go actually study our sun. We look at our sun in every single different wavelength. We look at all of the different activity. We have a wonderful armada of spacecraft that are all around our star, really making sure that we understand what our star is doing. And that's why we're really excited to be part of the Artemis mission to really take our exploration, take our astronauts back to the moon and beyond. Each of these spacecraft in key locations, giving us all of those really, really critical data to be able to better support our astronauts. So it's just a great time to be, as Jake said, it's a great time to be part of exploration.
So on Earth, we're safe from the increased solar activity from solar cycle 25. But things like spacecraft, satellites, and even astronauts in low Earth orbit could be impacted by the space weather that you just mentioned. So can we dive deeper into, what is space weather and how does the solar cycle affect space weather?
So the term space weather refers to the various conditions sun and in space that can influence the performance of technology we use on Earth and our assets and explorers in space, as you just said. The solar impacts are real. We see them whenever there's these space solar activity. Solar flares can cause radio blackouts that can impair HF communications important to airlines and emergency responders. The energetic particles can cause surface and deep dielectric charging of spacecraft, and that can cause buildup and damage the spacecraft's electronics and solar panels. The geomagnetic storms that develop from solar wind and coronal mass ejection effects on our magnetic field cause atmospheric heating, increased atmospheric heating, and increased drag for satellite operators that they have to deal with. The increased variability in the magnetic field protects us from particles from the sun. It can induce currents at the ground level, adversely affecting pipelines and damaging our electric power grid. So, and then on top of that, the ionized portion of the atmosphere departs from its normal state, affecting communications and navigation that we use for GPS and the navigation that we use every day in our phones, and the precision GPS used by airlines in surveying, farming, and drilling. And so these are just some of the effects that we care about here on Earth and in near Earth space, and why we monitor solar activity, and we're looking forward to this solar maximum and able to take care, watch what's.
And additionally, for our humans who are going to be traveling to the moon and eventually onto Mars, we have to consider other things. We certainly also worry about our electronics and our hardware and the impact on our people as well. But other things that you might not think about, like our pharmaceuticals. So if they take along some medicine to help with bumps and bruises or headaches or any other medicine that they may need, we don't know for sure how they'll respond to that radiation environment. And if they degrade at all over time, we need to know that. Same with the food. Does the food maintain its caloric value for us during a long trip to Mars and back? And so in addition to the armada that Nikki mentioned, human exploration is also putting some instruments in a place where they can contribute. We're developing something called the Gateway. The Gateway is going to be an orbiting vehicle around the moon that gets into a lunar orbit and gives us an opportunity to go from there down to the surface. But we can also conduct scientific experiments at the Gateway. So the first two payloads we've identified are actually intended to measure the space weather and heliophysics environmental conditions there. And that's kind of gives us the baseline so we can understand what the impact is on our hardware and our medicines and our food and our people once they get to that location.
Wow, that's really exciting that we're putting new instruments to measure space weather. So is space weather something we can predict at the moment?
So yes, I mean, we do a good job at predicting with the tools that we have. We make the scientific measurements. One of the great things about our Helio fleet is each asset is there doing groundbreaking science, but also the data are providing key inputs to all of the models that El Sayed was talking about that are helping us to predict. But of course, the real job for predicting our space weather is from the Space Weather Prediction Center. So I'll hand over to El Sayed to finish that one.
Yes, and it's a good handoff because we do that constantly between observation and the research that NASA does with the operations that NOAA does. A good space weather forecast begins with thorough analysis of all the near real-time ground and space observations of the current solar and geophysical environment from the sun all the way to the Earth. And space weather work at the Space Weather Prediction Center. They work 24/7. Analyzing the recurrent patterns of the solar activities you can see here as the sun rotates and look at active regions and compare those to past situations, and you're using the numerical models that we have ported from research efforts. They're able to predict space weather on timescales from hours to days to weeks. And we're not just doing that at NOAA, but just as the National Weather Service makes us a weather-ready nation, what we're striving to is to be a space weather-ready nation. And we're doing that in a multi-agency fashion. And that's with the National Space Weather Strategy and Action Plan, where we're working with NOAA, the National Science Foundation, the Geological Survey, and multiple other agencies to prepare ourselves from research to operations for severe events.
So we're going to be ramping up in solar activity in the next few years, being in the new cycle now. So what are we doing to protect our space technologies in space?
Well,
so we're creating
for human exploration. Okay. For human exploration, it's a big part of your prior question for predicting. If we know what the environment will be like, then we can prepare ourselves. So we can prepare on the long term. Al-Sayed talked about the different time scales. We can predict by designing our hardware in ways that they can be tolerant. But even on the shorter time scales, if we know that an event has occurred, then we can take certain mitigation steps. For instance, we could power down delicate electronics packages. We could end extravehicular activities and bring our astronauts in so that they can shelter in place in a protected location. So for us, it's kind of, having that predictive capability really gives us the chance to protect our crew and our hardware.
So let's go ahead and answer some of your questions from the hashtag AskNASA. Remember, please don't hesitate to send in your questions by writing in the comment box wherever you're watching this, or by using the hashtag AskNASA on social media. So our first question is from Per and Darlin on Facebook, and they ask, What is the prediction for the strength of solar cycle 25 at the peak?
So there are, honestly, you can talk to a number of different people and they'll give you very different answers. Certainly the last solar cycle we saw was kind of a small one. When you looked at that graphic at the beginning and looked at the previous 4, they were pretty big. And then the one we've just come out of was a pretty small one. However, even in that really small one in 2012, we actually saw the largest solar event that we've seen since the very famous Carrington event in 1849. And so even though the number of sunspots can be lower, that does not mean that there will be less activity. And so we're expecting to see something that's probably very similar in number of sunspots to the last one, but we're very much excited about getting a lot of activity and being able to test out all of our theories with all of the new measurements that we will be making. We've got new spacecraft that have come on since the last solar cycle. Very excited for personally because Parker Solar Probe launched just before the last solar minimum, about a year before. 7-year mission means that she will be able to take data from all of that solar cycle, all the way from minimum, all the way up to maximum. So totally new, groundbreaking measurements that we've never had before of our star.
So Vicky Smith on Facebook asks, where can we get current information about solar flares?
I'll say it.
Well, certainly the Space Weather Prediction Center gives us the solar and geomagnetic activity alerts. So you can find them online. You can sign up to a subscription service to get in your email about any kind of solar activity and solar watches, as well as geomagnetic activity in near Earth space. So you can find in real time what the activity is on the sun by going to the web page and looking at the space weather dashboard there. Obviously, for historical data and archival data, I mean, you're seeing some of the beautiful imagery that we get from space that NASA has, from the Solar Dynamic Observatory and from the NOAA SUVI instrument as well. So there's a wealth of data that you can have about solar flares from both space-based and ground-based observatories.
So Columbia on Periscope asks, what are sunspots and why are they dark?
That is a great question. And it depends what wavelength you look at them. And I'm sure we've got some wonderful videos that we can show you. But if you look at them in visible, so this is a lovely picture in visible, you can see that dark sunspot there that is rotating around, and it's about the same size as the Earth. And even though it looks dark and kind of boring and quiet, that's actually a pocket of very, very intense magnetic field. And so when we look at the sun in extreme ultraviolet, instead of seeing those dark splotches, what you see is a lot of activity, a lot of very bright spots. So the reason that it is darker is it's actually constrained. It is at a lower altitude to the rest of the solar environment around it, and so it's actually constrained at a slightly cooler temperature, and so it looks like it's kind of cool and boring, but actually it is very hot and very, very active.
So we have a question from Tim Swettens on Facebook. They ask, I've heard some people talk about the next Carrington event, a major impact by a coronal mass ejection that happens roughly every 450 years. How is this event already overdue to happen again? I'm sorry, how is this event already overdue to happen again? And to what extent can we predict coronal mass ejections? What can be done to prevent damage to our infrastructure should another event happen?
So I'll start and then hand over to Al Sayed, I think, for this one. Yes, it's very easy to say, well, the last Carrington event we saw was in 1859, sorry, but that was one that actually impacted the Earth. We know that these things are going off all the time. I actually mentioned that even during that very small peak of the last solar cycle, we saw a huge event in 2012, July 2012, which was, it actually did impact one of our stereos. So it went off the side of the sun. We were able to get all the data. And when we did the modeling, we saw it was actually much bigger even than the Carrington event that had happened 150 years before. And so we know that they're happening. It's just whether or not they are actually going to be coming to, whether the Earth is going to be in the path for them, and so, yes, we're certainly overdue for one to come straight towards us, but we are seeing big events on the sun much more frequently. And of course, now we have so many more measurements in space, it just means that we will be able to observe them, whereas before we would miss it because it didn't impact the Earth. I'll say it.
Thanks, Nikki. Yeah, absolutely. That 2012 storm, we missed it by 9 days, I believe, and that in a Carrington level. So lucky us. But what we're doing to prepare, this has been a priority for the last several years to prepare and cross-government, multi-agency effort, as I mentioned, to renew the National Space Weather Program. To drive us to a ready nation, to drive us transformation of space weather from a research-focused activity to a national operational priority. And so we've done this across the government, and where space weather has been into international, national, state, and local emergency management exercises, and including for aviation operations and daily operations of the electric grid. We have strong connection with our stakeholders there, in other sectors of our technological society, and including with the NASA as they astronauts in space. And just to follow on what Nikki is saying, the significant progress that we're making in observations from the research side is complemented by our plans on the operational side as well. We are going to the next operational space weather mission, the space weather follow-on, 2L1, which is upstream of Earth to get us the upstream measurements of the solar wind. It's going to ride along with the NASA IMAP launch. And IMAP is going to make great science that's going to help us advance our predictive capability. At the same time, the SWIFO, as we call it, SWAN, L1 is going to make the upstream measurements and the coronal imagery to look for these large events, the Carrington level events, and hopefully that we are able to hand off to our stakeholders, including space exploration, for mitigative effects. And here I'll see if Jake wants to add anything about that.
Yeah, that's a good question. What we really need to know is just what we need to prepare for, and exploration and science go hand in hand. And if we're going to send astronauts out into space, we need to understand what to expect. And so we can't really completely plan to avoid anything like that, but we can plan to be ready for it. And so one thing I like to say, and kind of co-opted this phrase, is that there's no bad weather, there's just bad preparation. So by understanding the data that's been collected by our colleagues and understanding the likelihood of events to occur, then we can prepare for that and we can build our systems that way. That's why we're going to the moon first. We want to go there and learn about living in deep space so that we can then make the much longer trek to a destination like Mars. So we really need to have science and exploration teamed up to be able to do that safely.
So Shiraz on Facebook, they asked, is space weather harmful to humans in any way?
Yeah, it is. And, you can become sick, you could become ill depending on the amount of exposure that you have. But as I mentioned, you can also try to mitigate that risk. So, here on Earth, you can get a sunburn. So you want to know what the weather's like. If you're going to be going out with no shirt sleeves on, you probably put on sunscreen. Out in deep space, we need to know exactly what those conditions are going to be like. So for instance, on our vehicles, we can design small shelter-in-place locations where Maybe it's not perfect, but it's at least better than it would be if they were in their spacesuit on an extravehicular activity. So we are very aware from decades of research that radiation does have an impact on our human bodies, but it is something that we can mitigate and prepare for.
Well, that's all we have time for today. Thank you, Nikki, Alsayed, and Jake for joining us. And thank you for submitting your excellent questions. For more information, visit nasa.gov/sunearth, where you can read more about today's announcement and watch videos that dive deeper into the science. You can also follow @NASASun on Twitter or @NASASunScience on Facebook for regular updates and news about our star. Thank you for tuning in and see you next time.